Hi everyone, my name is Hannah and me and my two other friends, Alif and Nara, have put up an experiment for our physics project to answer the question, does light travel in a straight line? Pretty interesting, right? Let's get right into it.
First off, what is light? Here's a fun fact for you. We can see 80% of the world around us using our sense of sight. But have you ever wondered why we can't see things in the dark? The answer is because there aren't any light in the dark. But wait. What even is light? Light is a form of energy which enables us to see our surroundings clearly. And the main source of light energy is none other than the sun. So, what exactly does light have anything to do with how we see? Basically, rays of the light bounces off objects and into our eyes, which allows us to see our surroundings.
Can all objects generate their own light? Not necessarily. Some objects can, but some objects can't. Luminous objects. Luminous objects are objects that can produce their own light, such as light bulbs, fireflies, thorns, stars, and of course the sun. Non-luminous objects are objects that don't produce their own light, such as us humans, plants, a pencil, and the moon, which you can only see because of the light reflected from the sun.
Now I'm going to talk to you about the 3 laws of reflection. The first law is that the incident ray, reflected ray, and the normal line are lying in one plane and that plane is always perpendicular to the reflecting surface. The second law is that the angle of the incidence is equal to the angle of reflection. And the third law is that the reflected ray and the incident ray are on the opposite side of the normal, as you can see in this picture.
Does light travel in a straight line? This question was extremely crucial to scientists in the late 80s. Does light travel in a straight line, a wave, or as particles? Light actually behaves both like waves and particles that behave differently, with different kinds of matter. Who proved that light travels in a straight line? An ancient Greek mathematician, Euclid, described the law of reflection in about 300 BC that states that light travels in a straight line and reflects from a surface at the same angle at which it hit it.
Alrighty, so me and my team here prepared just a little short video about an experiment that is related to our main question. Does light travel in a straight line? Here it is.
So we started off by drawing a line on the table so that the CDs will line up straight. We've already clipped the drawing clips on the CDs, which enable them to stand. Now we're just lining them up and making sure they're ready for the experiment. Now that that's done, we put a candle right in the middle of the CD's holes. Hey, let me tell you a fun fact. Those colors you see on the CDs, they're actually created by white light reflecting from ridges in the middle. Pretty cool, right? Anyway, back to the experiment. Right there we can see the light from the candle on the wall, because the light passed through the holes in the CD. But when we nudge one of the CDs to the right, hey, watch this. Suddenly, we can't see the light on the wall anymore. Why so, you may ask? Well, that's because the light from the candle was blocked by the middle CD and couldn't pass through, thus proving that light only travels in a straight line. If it didn't, the light could have passed from the sides, couldn't it?
We hope you enjoyed that little short video. So, our experiment proves that light does, in fact, travel in a straight line.
Alright everyone, it seems that we've reached the end to our presentation. As always, we hope that you enjoyed it as much as we did making it, and we also really hope that you learned a new thing or two. Thank you so much for your time, and we hope that you have a wonderful rest of your day, evening, or night.